Hey everybody, welcome back to another fun and exciting pre-calculus class. Today we will be launching into chapter number 6. That's found on page 104. Page 104. And what we'll be talking about in this chapter is, as you can see here, the trigonometric identities and formulas. What in the world? What's a trigonometric identity? Well, we've already been talking about some of the identities. What this chapter does is it kind of puts them all into one place, and then it helps us to work through them. This chapter is nothing more than a building block for chapter number 7. Really, nothing that you're going to learn in this chapter is going to really make a whole lot of sense to you. Just honestly, all you're doing here is you're learning how to switch things around, how to manipulate things, how to change things from sine to cosine, how to change things from secant to cotangent, something like that. So you're not going to really understand a lot of what's going on yet, but as soon as we jump into chapter number 7, you're going to go, oh, wow, okay, I get it now. I needed all that stuff in order to do chapter number 7. What is chapter number 7? It is trigonometric equations. So we're going to be solving equations, but in order to solve the equations, you need to know all of these identities and how to use them, how they function. All right, the fundamental identities. Let's go ahead and look at this. Two types of equations occur in mathematics. The first one is called conditional. What is a conditional? Well, you might remember this. This was in Algebra 1 and Algebra 2, actually. Conditional means that you get one answer for the variables. It's true of certain variable values. So, for instance, when you solve something, you get an answer, and you get one answer. That's a conditional. A second type is called an identity. An identity is true for any variable value. So in other words, whatever you plug in, it gives you that same thing. So, 4 plus 1 equals 2 plus 3. That's an identity because they both equal 5. And so like 4 plus, a equals a plus 4. That's an identity. It's just switched around, so it means the same thing. Here in Precalculus, we are going to be talking about a lot of different identities. What does that mean? Well, let's just kind of scan down here at table A, B, and C. We've already talked about some of these tables. The reciprocal identities. So that means that if I have sine, for example, I can find cosecant. How can I do that? By just flipping sine, because cosecant is the reciprocal of sine. I can do the same thing with secant and cosine. I can do the same thing with tangent and cotangent. Table B talks about the quotient tangents. Well, what is that? And we've already talked about these, but if you have the tangent of theta, it equals the sine of theta over the cosine of theta, or it equals opposite over adjacent. We've already discussed these things, but they're putting them all in one place so that you can come to get them. Where's the other place that these are all found? That's right, in the front cover of the book. So if you go to the front cover of your book, you're going to find all of these identities there as well. But they're just kind of putting them in another place altogether so that you can see them. Look at table C. I'm not sure we've seen this one yet. These are called the Pythagorean identities. What does that mean? Well, it means that they take sine, which is opposite, plus the cosine, which is the adjacent, or a plus b, right? A plus b, side A plus side B, equals side C. And they say, in this case, side C is 1. So if they put side C equal to 1, then once you square this and you square this, it's going to equal 1. Pretty cool identity, but it's all built on Pythagorean's theorem. Same thing is happening right here, only now we've manipulated the formula just a little bit. Now this tangent. What is tangent? Well, remember, tangent is, go back over here, sine over cosine. So there's your sine over cosine, and there's that. They're basically switching things up. What is the secant squared? All right, so it's all working off of the same information, the Pythagorean theorem, and what is sine, what is cosine, what are the quotient identities, what are the reciprocal identities. It's all based off the same information, but what these do is these help you figure out what, if you have a missing side, for example. All right, let's jump down here and talk about this. What's going on right here? This shows the second quadrant of an angle. So, in other words, the angle is in the second quadrant. Notice Pythagorean theorem is x squared plus y squared equals r squared. And remember, you can always do the same thing to an equation. You could multiply an equation by 10 if you wanted to eliminate a decimal. You could multiply an equation by the LCD if you wanted to eliminate the fraction, as long as what? As long as you do it to every single term. Well, look what they do to this one right here. So they say, let's take the Pythagorean theorem, which is x squared plus y squared equals r squared, or a squared plus b squared equals c squared, and they say, let's divide it by x squared. What's going to happen? Well, if they do that and they factor out the squared, that's the next step, and then you can see that as we cancel things and as we switch things, you're going to see this x over x comes out to 1, because anything divided by itself is 1, right? So there's 1. What's 1 squared? 1 squared is 1. What they're doing here is they're showing you how they came up with these Pythagorean identities. So there's where the 1 comes from, because they got it to cancel out. They created a 1 there. How did they do that? By taking the Pythagorean theorem and dividing everything by x squared. Well, look what else that you come up with. All right, so y over x squared. What's y over x? Opposite over adjacent. There's your tangent. Okay, equals, what's r over x? Okay, that's the secant. So that's where this comes from, is by manipulating, again, the Pythagorean theorem. It says here, the student is encouraged to derive the third Pythagorean identity, so basically do the same thing for this one. And what you would do is you would divide everything by y instead of dividing, or y squared, instead of dividing everything by x, and it will kick out this third Pythagorean identity. All right, turn the page over to page 105. Page 105. Each function was defined as even or odd, and that's been in previous chapters. And so what we find here is we have some odd functions. Sine is odd, tangent is odd, cotangent is odd, cosecant is odd. Then we have some even functions. Cosine is even and secant is even. A little change here in table D. We're going to call it now the negative angle identities. The negative angle identities. So when you hear negative angle identities, what is that? That's the even and odd function identities. Okay, that's it. Then it says here that the subsequent work, or the future work, in this chapter and in the next chapter, this is where, remember what I said about the next chapter. This is important for not this chapter necessarily, but really important for the next chapter, will be highly dependent. That's big time right there, okay? Highly dependent on the above fundamental trigonometric identities. That's these ones here and these ones back here. They say the above, but it's on the previous page, A, B, and C. 100% memorize these. No, you have to memorize these, because if you're constantly trying to flip back to see them, you're going to be in a mess. Memorize your identities, please. They've got them in the front cover. They've got them in different chapters. They've got them all over the place in this book. They are important. Now look, here's a helpful hint. Identities are true in many forms. Since tangent of theta equals sine of theta over cosine of theta, it is also true that tangent squared of theta equals sine squared theta over cosine squared theta. And you could do it this way. Basically, what you're doing is you're multiplying both sides, so you're getting sine by itself. So the sine of theta, when we get sine by itself, it is also equal to cosine of theta times the tangent of theta. So you can take these identities, start with the identity, and then you can manipulate them and move them around to different ways, different places, add squares, add square roots, invert them, all kinds of different things you can do, and they're still going to be true because they're identities. All right, let's jump down here and look at example number 1. You're like, boy, that was a long intro to this chapter. You're right, but I needed to go through it so that you could understand where we're headed and what we're doing here. I can't put enough emphasis on this because this isn't really going to make sense to you because you're going to be like, I know a different way to do it and it's a lot easier to me. That's fine, but you have to learn this way because you're going to need this when we get into the next chapter. Okay, so let's go ahead and look at this question. Given tangent of beta equals negative 3 over 4 and sine of beta is greater than 0, find the remaining trigonometric functions. All right, so the first thing that we want to do is we want to use our all students take calculus. Let's jump over here to this. And we are going to find out, okay, what quadrant are we dealing in? So let's use all students take calculus. Let's find out where we're at. So the tangent of B, tangent is negative. So where is tangent negative? Well, it's negative in the second and it's negative in the third. All right, so now we'll come over here and we'll ask, the sine of beta is greater than 0. What does that mean? That means that sine is positive, right? Greater than 0 means positive. So where is sine positive? Well, that's right here. So we are in, I'm going to write this here, we are in the second quadrant, okay? How did we figure that out? Take it piece by piece. Start with this. That's a negative, so tangent is negative where? And then you go to this, and where is sine positive, and you find out what quadrant that we're dealing in. So here we are in the second quadrant, and we have a negative tangent, and we have a positive sine. Those are the things that we know. Here's what the question is asking us for. The question wants us to find the sine, cosine, tangent, cosecant, secant, and cotangent. It wants us to find all of those. Now, we already have one of those. We already have this guy right here. So we have negative 3 over 4. So we can go ahead and write that in. So negative 3 over 4. Okay? So there we go. We have tangent is negative in the second quadrant. Now, one thing that we can do from here before we go on is we can actually put down all the different signs for all the different ones based on we're in the second. So sine is positive, that's going to be positive, and cosecant is also positive because these go together, right? Cosine is negative and secant is negative and cotangent is negative. Now, here's where you're not going to understand. Right now you're thinking, oh, I can just go ahead and fill in cotangent, no problem, because I know it's 4 over 3. And you're right, you're not wrong. Okay, but what we're going to do and what the problem is asking for, let's jump back over there real quick and just look at it. It says find them using identities right there. Okay, using identities. So in other words, we can't just flip it. We have to find an identity that allows us to flip it. Okay, and this is, again, this is connecting next chapter. So we need to know this so that we can do next chapter. All right, so how are we going to do that? Looking here, let's go back to our identities and let's find one that uses tangent and takes us to something else. Because the only thing that we have right now, the only thing that we're given in this problem is we have the tangent. That's all we have, okay? So let's go back over here to our identities and let's find one that uses tangent. So, and we only want one thing in it. So look right here. Here's one that uses tangent. So we could use that. We could use the reciprocal All right, so you can just come back over there and you can flip that. How can you flip it? Because you're using the reciprocal identity. And I don't need you to necessarily label what you've used, but you need to use a reciprocal identity in that case. And so we'll come back over here and we can go ahead and do that one. We can do cotangent is going to be 4 over 3. How did we get that? Reciprocal. Okay, and you need to know what you're doing. Don't just, like kind of guess or jump around. Now, one thing that you're thinking is right now, okay, I have the opposite and I have the adjacent. So I can find the tangent, or I can find the r, I can find the hypotenuse by Pythagorean theorem. Well, you're right, but in this case, we're using identities, so what are we going to use? Well, we're going to use a Pythagorean identity. Which one do you want to use? Well, the one that we really need to use is the one with tangent in it, okay? Because that's what they gave us. That's our given for the problem, is the one with tangent. So let's go ahead and do this. We'll use this one with tangent right here. All right, so here we are. I've got the identity written out, and we know that we could just plug in right now to this, and we can plug this in right here. Negative 3/4. So 1 plus negative 3/4 squared equals the secant squared. Okay, and that's theta. I think they use beta in your book, but I'm using theta because I just am. Now, what we want to do is we want to get secant by itself. Well, it already is. Look. Well, yes and no. One thing, sometimes it's easier just to put everything on the left side. I don't know. You can do that if you want. The secant squared theta. Basically, I'm just switching these two things. Why? Because maybe it's easier for you to see it that way. Equals 1 plus negative 3/4 squared. And now what I want to do is I want to do something. I want to get secant by itself. That's my goal. So I can square root both sides. I have to square root the whole side there. Okay. And what happens here is I get cancels and I get secant of theta. That's what I'm after. That's what I'm going for. I'm trying to find this one right over here. That's what I'm looking for. And now I get the square root of 1 plus negative 3/4 squared. Okay. Now I just have to do that. And to do that, I would do secant of theta equals square root of 1 plus negative 3 squared is going to be positive 9 over 4 squared is 16. Well, I can't really add these, right? I have to have a common denominator. So I could have secant of theta equals 16 over 16. How did I do that? Well, 1 equals whatever, so I just found a common denominator, which was 16, and made it 16 out of 16, which is 1. 16 of 16 is 1, plus 9 over 16. Now I'm just going to add those together, so the secant of theta equals the square root of, that is 25 over 16. And now remember this is kind of like an algebra 2 concept, but the secant of theta equals the square root of 25 over the square root of 16. Remember that you can do that, which is going to equal 5 over 4. That's going to be our answer for secant. Secant equals 5 over 4. Now it's not 5 over 4 because remember we drew our sign in here first. It's negative 5 over 4. Where did that negative sign come from? Well, it came from all students take calculus. We had to put in that negative sign. And then what you would do is you would just keep going through these different identities. And every one is different. So that one was using the Pythagorean. This one is the reciprocal. That's them finding cotangent right there. So look up here. We already found the secant, right? Now we can use the reciprocal identity to find the cosine. Why? Because secant and cosine are related. So there's the cosine, negative 4 over 5. And now the last thing that we can use is we can use the quotient identity, because this is interesting with the quotient identity. Look, we couldn't use the quotient identity at first. Why not? because we had two variables. All we had was tangent, and then we had sine and cosine were both variables. But now that we have cosine, where did we get cosine? Right here from the secant, negative 4 over 5. Now that we have the cosine, now we have two. We have tangent, that was given, and we have cosine, we figured that one out. Now we can find the sine. How do you do that? By multiplying both sides by cosine, and then you just multiply them together. Look right here. We multiplied together. We have 4 times 3, that gives you 12. 5 times 4 gives you 20. You reduce 4 over 20, and you get 3/5. Okay, so there they are. There's all the different ones that we found. And again, you might be thinking, "Oh my goodness, Mr. Steve, that was so hard to do. Why didn't I just use Pythagorean's theorem? This would have been so much easier if I would have just used Pythagorean's theorem." I know, right? Well, you need to get used to this. You need to get used to doing it this way, because in the future lessons, you're going to have to use these identities. You can't go back to Pythagorean's theorem. You have to use the Pythagorean identity, and you have to do other things there. Okay, so hopefully that made sense to you. I know it's a little bit longer lesson there, but I wanted to kind of get through that and wade through a lot of that kind of difficult, challenging stuff there. Okay, all right, hope you learned something. If you didn't, scroll it back and watch it again. See you later. Bye-bye.